Compound inequalities. It's when we're talking about more than one equality, specifically two inequalities together. We're going to talk about two different kinds of inequalities. We've got the and inequality and we've got the or inequality. First, we'll talk about the and inequality. When you see the word and, you're looking at that both inequalities are true, both of them, not just one. They have to both be true for the whole thing to be true. So let's look at an example. X is the number of days you go to school in a week. So if you think about it, as far as the fewest number of days that you could go to school, you can't go to school less than 0 days. So X has to be greater than or equal to 0. Right? So you can't go negative one time. So you need the number of days you go to school to be more than 0, or it could be equal to 0. This summer, you didn't come to school some weeks at all. Okay? And on the big side of things, you're not going to go to school more than 5 days in a week. You may come for sports, but I'm talking about actual school. So X also has to be less than or equal to 5. If it's greater than 5, you're coming to school too much. Now, this is one way to write it. You'll see this many times. You can also write it not having to do the and you're only going to write X once. So if I just write X once, and I focus on this one right here, X is bigger than 0. So I need to make sure that when I draw my inequality here, that it says that X is bigger than or equal to 0. And then if I look at the other one, this is saying X is smaller than 5. So on the other side of X, I'm going to say that X is smaller than or equal to 5. And this is another way. Now, this is only, you can only use this way for and, or you cannot use it this way. And is the only one that has the two ways to do that. Now, as far as the graph goes, you know, if we were to start to graph and just honestly think about it, I'm looking at two things. I'm saying that X is equal to 0 and bigger, and I'm saying X is equal to 5 and smaller. But remember, both things have to be true, so we have a problem. Right here, X is bigger than 5, and that's only true for one of them. It's not true for when X is less than or equal to 5. So this spot right here can't happen. The same as this spot over here. This spot right here can't happen because it's not true for the X is greater than or equal to 0. So ultimately, when we're doing this, we want to only look at the stuff that's true. So I'm going to rewrite this and I'm going to say, okay, new number line, I've got 0 and I've got 5. It's greater than 0, it's less than 5. They're both true in between the two. And so an and statement looks like this, where it's connected. It might have open circles, it might have closed circles, but it's connected in between. So now let's look at solving an and problem. It's as easy as solving an inequality. You just have to do it more than once. So if we look at this first example, we subtract 7 from both sides. The 7's cancel out, X is greater than negative 2. I didn't switch the sign, I wasn't dividing or multiplying by a negative. On the other one, I subtract 7 from both sides. X is less than or equal to 13. Now, here is part of my answer. And so one of the big parts of my answer is the fact that this is an and problem. So I need to put an and in between. This is a big part of my answer. But I'm only part ways there because the other part of my answer is the graph. And we always need to graph these. So we've got negative 2 and we've got 13. Make sure you put them on the number line in the correct order. It's kind of ridiculous if you switch them. Number lines always go from least to greatest. Now it says X is greater than negative 2, so it's an open circle to the right. And it says X is less than or equal to 13, so it's a closed circle and to the left. And so here's the other part of my answer, this graph. And I want to see them both. I need to see your work. I need to see both parts of the answer for you to get full credit here. Now, it's a little bit more difficult when we have the other form of the and. You'll notice here I have X plus 7 in between two different inequalities. And so what your goal is always to get X by itself, and it has a plus 7 with it. So what I'm going to do is I'm going to get rid of the 7. But I need to get rid of 7 everywhere. So I need to get rid of it on the left side, and I need to get rid of it on the right side also. So now I have 5 minus 7 is negative 2, less than X. That canceled out, is less than 13. And if you'll notice, this is the same problem as before. I've got a negative 2, I've got a 13, and open circle, X is bigger, closed circle, X is smaller. Now you'll notice I don't have to do an and on this one because if you remember, and, or ones that are connected like this only are for and, ors can't do that. So go to the next problem. I look at the t and I say, hey, I got to get rid of this 4, so I get rid of the 4 everywhere, outsides, both outsides. We've got negative 13 is less than t is less than 6. And so that's part of my answer. This is an and problem because it's connected like that. I graph both numbers on the number line. Okay, this is saying t is greater than 13, so it's an open circle to the right. On the other side it says t is less than 6, so it's an open circle and to the left. And there's my graph and my answer. Then we have the last one here. It's a few more steps than what we've been doing. Okay, once again I look at my t. I've got a 3 and an 8. I get rid of the 8 first. So I'm going to add 8 to inside and both outsides. We get 6 is less than or equal to 3t is less than or equal to 18. And then I divide everything by 3. 6 divided by 3 is 2. T is less than or equal to 6. So then we can graph. We put our 2 and our 6 on there. They're both closed circles. This says t is greater than 2 and it's less than 6. So there's our graph. Again, if it's not put together like this, if it says an and, you need to make sure your answer has the and in it also. And then, just real quickly, we have our or statements. Now, or statements are saying, you know what, they don't have to both be true. Only one of them could be true. Now, most of the time, that's the only case. Only one of them is true. Sometimes you have weird situations where they might both be true. You can think about that if you want. Maybe you can tell us in class what you think. But let's just look at an example. Okay, let's say X stands for the amount of money that I make in a year. Now, with my math degree, this could actually vary quite a bit. I've chosen to be a teacher. So as a teacher, I'm going to make less than or equal to, let's just say 50,000. I'm not actually going to talk to you about what I really make, but let's just say it's 50,000. Or if I wasn't a teacher, if I went into business with my degree, I could actually make quite a bit of money. And let's just say that that would be at least $100,000, at least. Most of the time it's going to be actually quite a bit more. So if you look at this both can't be true. I can't make less than 50 and more than 100. So only one of these is going to be true, depending on which occupation I chose to go with. And so graphing this, 50,000 is smaller, so it goes to the left. 100,000 is bigger, so it goes to the right. X is less than or equal to 50,000. X is greater than or equal to 100,000. And if you look at this, now this is interesting, an OR graph goes in opposite directions. They're going to go away from each other, which makes sense. Because if I'm right here, there's no way I could also be over here. Whereas on the and, they overlapped in spots. So an OR statement goes in opposite directions. Now if we look at graphing this, if we look at solving this, all I have to do is solve each one separately and graph. So I get rid of the 3 on both sides, 2x is less than 2, divide by 2 on both sides, x is less than 1. Over here I add 7 to both sides, 4x is greater than 16, divide by 4 on both sides, x is greater than 4. Now remember what I said, it's really important we include that word or in there as part of our answer. So here's part of it. The other part is my graph. I've got a 1 and I've got a 4. Now it says x is less than 1, so it's an open circle to the left. And then it says x is greater than 4, open circle to the right. And so there's this part of my graph where they go in opposite directions.